There's this hidden world humming just beneath the surface of our daily lives. Seriously, it's not science fiction. It's this huge, decades-old digital foundation that powers pretty much everything we do. Today, we're going to pull back the curtain on the massive challenge of keeping this world running and the powerful new tools being used to try and save it. Okay, let's get into it. So, right at the very heart of our global economy, there's this invisible crisis. We're talking trillions of dollars, critical government services, global travel, you name it. And it all depends on computer code that is in some cases over 60 years old. It's wild. Let's start with a number that's kind of hard to wrap your head around, $3 trillion. Now, that's not the size of some country's economy. Nope, that's the value of transactions that run every single day on a programming language from 1959 called COBOL. For more than 60 years, it's been the quiet, unbelievably resilient engine of global finance. And to make that huge number feel a bit more real, just think about the last time you went to an ATM. 95% of all ATM operations run on COBOL. That simple act of getting cash, it's powered by code written before we even walked on the moon. And this is where that code lives, on these powerful mainframe systems. Now, when you hear mainframe, you might picture some dusty relic in a basement, right? But that's not it at all. These are the super secure, incredibly reliable workhorses that are still the cornerstone for the world's biggest organizations.
The big problem with all this old code is something developers call technical debt. Just think of it like regular financial debt. All the shortcuts and quick fixes made years and years ago, that's the principle. And the interest you're paying is all the complexity and risk that slows down new ideas today. Well, that debt is coming due.
But here's the twist. A powerful new player has just entered the game, and it's promising to help us pay down this decades-old debt and bring these critical systems into the modern age. And that player is, of course, artificial intelligence. This new way of working has a pretty cool name, vibe coding. It's less about a developer manually typing out every single line of code and more like this fluid, conversational partnership. You, the developer, guide the AI with plain English prompts. You're basically vibing with an AI partner to build and fix software at a speed that was unimaginable before.
The whole philosophy behind it is code first, refine later. The big idea is to let the AI quickly whip up a functional first draft. This completely frees up the human developer to focus their brainpower on the really hard stuff, the overall architecture, the complex business logic, and making sure the final product is actually safe and reliable.
So what does this actually look like in the real world? Well, it's a pretty clear playbook. First, you have to understand the old system. Then, you use AI to build a modern shell around the old code. This kind of contains it. Then comes the magic part. You can actually translate entire chunks from old languages like COBOL into modern ones like Python. After that, you untangle the messy logic, and, this is so important, you use the AI to write automated tests, creating a safety net that probably never existed before. And the business reason for doing all this? It's just staggering. A recent survey found that the one-year return on investment for these modernization projects is absolutely massive. We're talking 114% for projects that stay on the mainframe, all the way up to an incredible 225% for those that move applications off of it. The push to modernize is just huge. But this is where our story takes a sharp turn. Because this powerful new hero, this AI, it comes with a hidden cost, a dangerous side that can actually make the problem of technical debt even worse. And here's the central conflict. On one hand, you have these undeniable productivity gains. Developers are getting stuff done up to twice as fast. But on the other hand, AI-generated code often gets a pass on security checks, and most importantly, it has no idea what the larger system looks like. It risks creating a brand new kind of technical debt, one that's being built at superhuman speed. And look, this isn't just some theory. The data shows a real drop in code quality since AI assistants became popular. One analysis found an 800% increase in duplicated code and a 200% increase in code churn. That's code that gets written and then almost immediately rewritten. Another report found that a 25% increase in AI use led to a 7.2% decrease in delivery stability. Not great. And this quote from the MIT Sloan Management Review just nails it. This is the core issue. The AI can write a perfect little piece of code, but it can't see the entire system. It doesn't understand all the complex connections or the design choices made years ago. It just can't see the big picture. So, the big question is, how do we use the incredible power of AI without falling into all its traps? Well, it's going to take a new playbook, one that's a lot smarter and more disciplined. The most important thing to get is this. The developer's role is changing. It's not just about writing code anymore. The AI becomes the assistant. It handles all the boring, repetitive stuff. The human developer then gets to level up. They become the architect and, maybe most importantly, the risk manager. They set the goals, they review the AI's work, and they make sure the final product is secure, scalable, and actually works. This quote from a developer at a huge tech company gets right to the heart of it. AI can give a junior developer the speed of a senior one, but it can't give them the experience or the judgment. That cognitive sense of knowing whether you're solving a problem or just creating a bigger one, that's what makes a human expert completely irreplaceable. Ultimately, this all points to a much more practical way forward. It's about working smarter, not just faster, to finally breathe new life into these critical old systems. So, this new playbook gives us a clear, sensible strategy. Instead of a super risky, all-or-nothing big bang rewrite, the smart approach is to do it piece by piece. You use AI to first understand and document the old code. Then, you fix the most important parts one at a time. And finally, you build bridges with modern APIs, letting the old and new systems work together peacefully. And that brings us to our final question. Is AI the ultimate co-pilot, here to boost our skills and speed up innovation? Or is it a new kind of saboteur, quietly planting hidden risks that could blow up on us tomorrow? Well, it seems like the answer depends entirely on the wisdom of the human sitting in the architect's chair.